Okay, this video is going to look at solving systems of three equations with three unknowns. So what it is actually planes in space, and we're looking at where the planes intersect. So what we want to look at when we have this system is try to figure out what would be a good one to eliminate. Well, if I inspect this, I have a single x, and one option you can also do is like solve for a variable and then plug in. The goal is to get down to two equations and two unknowns, something we're used to doing. But I'm going to look at this one, and I'm going to choose to get rid of the z, because if I take this equation and I multiply it by -2, when I add it to the top equation, the z's will cancel. If I multiply the middle equation by -3 and add it to the bottom equation, the z's will cancel. So that's kind of the first one I have. So I'm going to take this equation right here, and I'm going to multiply by -2. And I rewrote the top one. So when I add these together, I'll get 3x plus y is equal to -7. Then always check. This is where students always make mistakes. They don't multiply everything all the way out, or they make an addition error. Because when you make an error, you won't know it until you start getting to your answers. Okay, so now I'm going to look at trying to eliminate z again. So I've got to get rid of the same variable twice. So this time I'm going to multiply this equation by -3. Then I get -3x plus 6y minus 3z equals -15. When I add that to the bottom equation, I'll get -x plus 10y, my z's cancel, -15 and 7 gives me -8. Now I'm down to two equations, which is my goal. I want to get down to two equations and two unknowns. Okay, so now it's just like doing a normal kind of a problem. So I'm going to multiply the bottom equation by 3, so when I add them together, the x's will cancel. Adding these together, I get 31y equals -31. So I got y equals -1. Now, if you get some nasty fraction, you get something like 31 over 27, go back and look for an arithmetic error, because chances are that's going to be the case. Because usually we'll try to make the answers come out really kind of nice. So if you don't see a nice answer coming up, it's possible, but it makes it worthwhile to go back and say, oh, did I mismultiply something, or did I misadd something? Okay, once I know what y equals, I'm going to take y equals -1, and I'm going to plug it back to either one of these two equations. In this case, I'm going to plug into this top equation. Then I can solve for my x. So I end up with x equaling -2. Now I know what x is, I know what y is. Now I got to figure out what z is. So I'm just going to plug it into the middle equation here. And I could have plugged it into any of the equations. So I've got -2 minus 2 times -1 plus z is equal to 5. -2 plus 2 gives me 0, plus z equals 5, so therefore z equals 5. So that means the planes, the point where they intersect, is at the point -2, -1, 5. Okay, let's look at a little bit harder example where it's not quite as easy to figure out what to get rid of. Well, the x's wouldn't be terribly bad, because I can multiply this equation by -2, add it to the middle one. Multiply the top equation by -3, add it to the bottom one. I can get rid of my x's. That would be fine. With the z's, the y's, about the same thing. But let's say here's a technique that tends to work. If you have one of the signs as an opposite sign. So what I'm going to do is I'm going to combine these two equations together to get rid of the y's. So since they're opposite signs, all I got to do is get them to match. So if I take the number that's here, and I take the number that's right here, and I multiply my equations across, when I multiply them in, they're going to match with opposite signs. So I got 6x plus 15y plus 9z is equal to -24. 20x minus 15y minus 35z is equal to -15. Then go back and check because the most common mistake that gets made is forgetting to multiply the constant that's out here. So make sure you do that. Now when I add these together, I get 26x, the y is canceled, I get negative 26z is equal to negative 39. Now we have, I'm going to try to get rid of the same thing again. So we are going to go and I'm going to multiply to have these two match up. So I put a 2 here and a 3 here. See, I just took the number. They're already opposite signs, so it's a nice little technique that works really well. This gives me 8x minus 12y minus 6y minus 14z equals negative 6. And then this one, I get 18x plus 6y minus 15z is equal to negative 39. Again, the goal here was get those y's to cancel. So when I add them together, I got 26x minus 29z equals negative 45. Now I'm down to this and this as my two unknowns. Well, it just happens that on this case, it got to be a little bit easier because my x's matched up. So I'm just going to change the signs of that bottom equation so that when I add them, the x's cancel. This gives me 3z equaling 6. So z equal 2. Now I'm going to find out my other answer, so I work backwards. If z equals 2, I'm going to plug it back into one of the two equations. In this case, I chose the top one. And then solve for x. So I got 26x minus 52 equals negative 39. Add 52 to both sides. I got 26x equals 13. And I get x equals a half. And that's probably the worst kind of number you'll end up with as a fraction. So I get a little nervous when I see that fraction. It tells me maybe I should go back and check my algebra. But I do happen to know that the algebra was correct on this. Okay, so now I'm going to plug back into one of these equations up here to find out what in this case, y is. So I plugged it into the top equation. So I have 2 times 1/2 plus 5y plus 3z equals negative 8. I get 1 plus 5y plus 6 equals negative 8. So I got 5y plus 7 equals negative 8. So 5y is equal to negative 15. And y equals negative 3. So those planes would intersect at the point 1/2, negative 3, and 2.